and welcome to our second lecture. In this one, we're going to talk briefly about variables and user interaction. So we're going to learn how to communicate with the user. We have to learn about variables first because the user interaction generally requires us to use variables. So what are variables? Well, they're one of the fundamental and most useful concepts in programming. They're a way for us to store values in the memory storage of the computer's RAM chips. That's random access memory. And they work a lot like a math variable. So when you say something like x is equal to 5 in math, then you're saying that x has the value of 5. We write it the same way with x equals sine 5, but a programmer usually says x gets 5. There's a reason why we say that, and it'll become obvious later when we get into doing comparisons. But that's a future lecture. For now, we're going to talk about variables in the context of a Python program. Now, the big thing about variables is that they can change. It's right in the name, variable. They can be assigned a value, and then at some future point, they can be reassigned a different value. They can be updated. Now, although Python doesn't require it, we normally use a variable with only one type of data. If we use a variable and use a whole bunch of different types of data, it can be very confusing to remember at this point, is that representing a number or a string or what is that? So we generally use it with one type of data. So when we update, we usually update with the same type of information. A variable, unlike a math variable, can hold different kinds of data. For example, the string literals that we saw in the previous lecture, those can be assigned to a variable. And we'll see that in a demo in just a couple of minutes. So data can be strings, data can be numbers. Numbers can be integers, or they can be floating point values. Integers, of course, have no fractional component. They don't have a decimal point. Floating point values have a decimal point and a fractional component. There's a whole bunch of other types, but we'll see them later. We're not going to worry about those right now. So our first problem for this lecture will repeat the second problem of the preceding lecture. Remember the one where we had you print your name, your birthplace, then we had you print your age, and your favorite ice cream. We're going to do the same thing, except instead of hard-coding the string values right into the print statements, we're going to assign them to variables and use the variables in the printing. Now, there will still be some hard-coded parts, and you'll see what I mean when we get to the example. Print allows you to print information that is stored in a variable, and we will see how that's done in this process. And recall again, name in international format, their birthplace, their age, and their favorite ice cream flavor. Let's see how we do that. Okay, moving on with the first problem from Lecture 2, we are going to basically redo the personal preferences project, but we're going to do it using variables. So we're going to start another new project. This time, we're going to call this one Lecture 2, Problem 1. Same setup as before. Again, we never need this welcome script. It's of no use to us. And we'll create that. And as always, I'll move this to full screen. And I'm going to create my Python code for this. New Python file. And to make life easy, I'm going to call this L2P1. So the last time we did this, we used print statements, and in the print statements, we provided literal strings to provide the information. This time, we're going to put the information into variables. To declare a variable, we simply give it a name. In this case, it's actually called name. And then we put an equal sign, which is the assignment operator in Python. I read that as gets. And then we can put in the information, like so. So what I've done here is I've declared a memory storage space that will hold a string, and that string is my name in international format. The second thing I need is my birthplace. And I'm going to assign that Abu Dhabi, just like I had before. Third thing I need is my age. Now this time I'm just going to type it as a number. Notice the change in color. That's because this is an integer value. And finally, I'm going to create ice cream. Note the underscore. You cannot use a space in a variable name. So instead of a space, we use an underscore. And I'm going to put in salted caramel. Now, that places all of this information into variables, but we want to print out the former labels that we used to show what that information was. So here's how I can do that. I can say print name colon, okay, and then I'm going to put comma name. Okay, so print can take a list of things to print out separated by commas. I can do the same thing with birthplace. Like so. I can do the same thing with age. The thing about using the comma is that the age will be recognized as an integer and it will get changed into a string because it's a separate element, and print knows that everything has to be a string for it to be able to print it. So it will do that for us. Later on, you will see why this would be a difficult thing. Okay, so favorite, I should put in favorite here. Favorite ice cream. And ice underscore cream, because that's the variable that I created above. Okay, so if I've done everything correctly, I should be able to run this. Let's see if I can. Okay, so it ran it and printed name, my name, birthplace, location, my age, and my favorite ice cream. Process finished with exit code 0. So it looks like everything is good. So what's different about this than last time is that we have used variables. So I could go in and change a variable. Like if I were to have a birthday very soon, I could change this to be 55. And then when I go and rerun it, the age will be updated down here in the output to be 55. Okay, so that means that this statement doesn't change. Only what's stored in the variable gets changed. That's a really important concept that we are going to use throughout this course. So now we're going to move on into user interaction. A Python program itself is really only useful if you can supply it with information to process. Now, while you can write that information directly into the program, either, like we did with print statements, in literals, or assigning values directly to variables, that's really only useful if you're a Python programmer and you know how to modify a Python program. Most ordinary people have no idea about Python programming or any kind of programming. So if a person doesn't know how to write Python programs, that's not going to be overly useful to them. It'd be nice to be able to interact with the program's user and allow them to simply supply the information, and behind the scenes, we do all the work for them. Think about something like Microsoft Word as an example. There's a lot of stuff that goes on to allow that text to be processed and presented on a printed page. We don't see that program code, but we do learn how to use it, and we do get certain signals and prompts. Of course, they're not using a console for that program, they're using a graphical user interface, but the concept is the same. There's user interaction involved. It's important to tell the user what we expect. If you had a pop-up appear on your screen with a blank in it and nothing else, you would have no idea what it's asking you for. So we have to be able to tell the user what it is we want them to enter. Otherwise, they're just going to have a flashing cursor, and they'll have no idea how to answer the question that's being asked because they don't know the question. We already know how to generate output to the console via the print statement, but to receive input, we need to use the input statement. That sounds pretty logical. The input statement takes an argument. So, like our print statement, you can put an argument in, which is what you want to print. Well, this one takes an argument, which is a string called the prompt. That's the thing that tells the user what information is expected. Usually, you assign the return of the input statement to a variable. So in other words, you have some variable gets input with a prompt. You'll see how that works in just a couple of seconds. Input statements always return strings, but those strings can be converted to other types when it's appropriate to do so. Now let's look at our problem again. Same problem as for the first question this time, which is a repeat of that second problem, except that now instead of hard coding the variable values, you're going to ask the user to supply the information for the variables. Recall that input returns a string, so we will need to convert any numeric strings into the appropriate data types to make our code work. And recall that, again, we need the person's name in international format, their birthplace, their age, and their favorite ice cream flavor. Now let's work on the second problem of Lecture 2. So we're going to set up a project just like we set up here, except with the name Problem 2 on it. So Lecture 2, Problem 2. Also leaving the main.py out of it because we don't want it. Now I'm going to go in, right-click, New Python File. You should be getting very used to this by now. And L2P2 to follow the previous format. Now this time we're told that we are to input the values. So before I had name and then I typed in what I wanted. This time I'm going to put in an input statement along with the prompt. Now notice one thing. The prompt, if you leave it like that, the cursor would be right after the colon, which looks kind of funny. So we normally put a space as the last thing in the prompt. It just looks better. Okay? Now age can be read in as a string, but I could get it as an int because, remember, in the previous one, I just typed it without quotes around it. So that would be the int of the input of age. Okay. Now, I didn't ask my birthplace in the right order, but we're going to see something here that's important. Birthplace. Okay, so I'm putting that in this order. Don't panic. Okay, and ice cream input the favorite ice cream. Now we're going to do the printing the same as before. I'm going to give myself a little more space. Maximize this. So this time I'm going to print, and just as I did before, I have to print out name because the prompt is not included in the variable name. The prompt is just to tell the user what to do. Okay? And this time I'm going to use a concatenation operator. And I'm going to tell it to concatenate name. So this time I put a space after the label, and then I used a concatenation instead of a comma. There's going to be times when you will want to do this because you don't want the extra spaces that are automatically added when you use the comma form. Now I'm supposed to give my birthplace. And there's the variable there. I can use the completion if I want. So birthplace comes next. Even though I didn't enter it in that order, I can present it in whatever order I want. Okay. Age. And I'll put age in here. Notice there's a little warning there. We'll get to that in a minute. And then finally, favorite ice cream. Okay, so this looks like it should be good. We've used things the way we have in the past. Will it work? Let's find out. Okay, so it's coming up and it's asking for the name. You can see it down here. So I can click in the window and I can answer it. It wants my age. I'll put in my age right now, 54. My birthplace, Abu Dhabi. And favorite ice cream, salted caramel. Now, when I hit enter, after I've gotten all of those, I get an error. It printed out my name, it printed out my birthplace, but then it failed. And it says here on line 8, print age, concatenate age, type error, can only concatenate string, not int to string. Well, remember I said we were going to convert age into an int exactly the way it was represented in L2P1. Remember, I didn't put quotes around it. So this also is an int, and that affects how concatenation works. To fix this, any non-string value has to be converted to a string. So we use the built-in str function to convert age into a string. Now when I run it, it will ask me for my name. Click down here. It'll ask for my age. It'll ask for my birthplace. And it will ask for my favorite ice cream. And this time, exit code 0, and it printed correctly. Name, birthplace, age, and favorite ice cream. That's all it takes. Very, very straightforward. So far, we've learned how to take things that we used to print with literals and to assign them to variables instead, making it easier to make changes. And now we've learned how instead of just having them assigned to variables, but having them be static strings, we can type in whatever we want and provide that information. If I were to put in here, I should do international format like I said I would. Alphonse Pickles. Alphonse is 19 years old. Alphonse was born in Sheet Harbor. And Alphonse's favorite ice cream is pickle. Well, that's not surprising. You pickle ice cream. But it works. The name, the birthplace, the age, and the favorite ice cream are all what we typed in. That is what is powerful about this concept. Anybody who runs the program can supply information, and we can do things with it. Moving on to problem 3, we're going to write a program to compute the area and perimeter of an equilateral triangle. The formula for the area is shown here. The area is the square root of 3 over 4 a squared, where a is the side of that triangle. What would be the perimeter? Think about it for a minute. Well, if you think hard about it, you'll realize that the diagram shows each side is A. So therefore, the perimeter, which is the outline of the triangle, will simply be 3A. Now, if we were to supply a value for A of 3.5, then it would compute the formula shown at the bottom, which would be root 3 over 4 times 3.5 squared, which would give us approximately 5.30441, so the area is approximately 5.3. You should be able to use that with your program to come up with the appropriate solution. You can check it. What would be the perimeter here? Take a few seconds to think about that. Well, it's simply 3 times 3.5, which would be 10.5. Check your program and see that it works the way you expect. Once you've got it working, congratulations! Reward yourself with an extra trip to the refrigerator for dessert tonight. You've actually written a program that takes user input and does computations. Now we're going to solve the final problem of the lecture, the one about the equilateral triangle. Again, new project, Lecture 2, Problem 3. And we're going to add a new Python file, L2P3. Now I'm going to put in something that you haven't seen before. I'm going to put in a block comment. I'm going to use the triple double quote system to do this. Okay? And I'm going to write up that we are going to produce the area and perimeter of an equilateral triangle. Okay. So this is one way that we can put in information. And I could put in my name, and I could put in today's date. Now, you might be seeing this a year or two from now because these videos are all very basic, and the concepts are pretty much universal. So don't let that put you off. If it's 2025 or 2026 when you're seeing this, hey, time passes. I mean, what else does it have to do? Okay, so first thing we need to be able to do anything is we need to have the length of the side. This is called a line comment, okay? That hash symbol at the beginning, which is technically called an octothorpe, that is asking us to input the length of the side. Well, that's telling us that we're going to do that. And we want to make sure as a floating point number, because there's nothing that says that the side of an equilateral triangle must be an equal unit, an integer unit. So we're going to do that. So a good name to use would be side. You might be tempted to use S, or even as the math diagram that we used in the lecture showed, A. But mathematicians tend to use single letters, but they confine it to just that problem. We're going to get in the habit of using more descriptive variable names, because in bigger programs that's vital, or you'll get really confused and not be able to actually figure out what is going on in the program. So side is, now we need to make this a floating point number. Well, we used int to change from an integer, okay, from a string value, I should say, into an integer. Well, we can use float to change the input value from text, which is a string, into a float, okay? So I can say here, enter length of side. Awesome. So we have a couple of formulas that we defined. First of all, in our discussion, we determined that the actual perimeter of an equilateral triangle would be the sum of the three sides of the triangle. That would be true of any triangle. But when we're talking about an equilateral triangle, all of the sides are the same. So therefore, when we input the side, it will simply be 3 times the length of the side. So we can now make a variable called perimeter, which will be 3 times the length of the side. Okay, that asterisk character, asterisk is Latin, aster meaning star, isk being an ending that you put on to mean little star. So that symbol means multiplication when you are writing Python code. You'll see that a lot in math and computer science courses, and even in stats courses, because you're going to be using other systems, but that's pretty much universal. Now, the only other thing is the area. And the area is given as the square root of 3 over 4 times the side squared. Well, we would get into this in more detail in the course, but suffice it to say that there are ways to do this. And if you were to look in the standard reference materials for Python, you would find that there is a math library. Okay? And we're going to need to use that math library. There's going to be something else we need, but we'll discover that in a minute. So the area is the square root of 3. So that's math.sqrt of 3 divided by 4 times side, and we can square side the simple way by using the double multiplication sign. When you use 2 of them in a row, that means exponentiation. There is also a math function called pow that will do the same thing. You would put side and then comma and then 2 as the argument to pow. But this will work for us. Okay? So I can compute perimeter based on the input side, and I can compute the area based on the input side. Awesome. Now all that remains, I'll put in a comment, report the results of the computations to the user. So now I can print perimeter of an equilateral triangle of side, and now I want to put in the side. Well, remember that the side is not a string. It's a float, but we don't really care. It's just not a string. So I can put in concatenate str of side, concatenate. Notice that I have to put spaces on either side. When you concatenate, there's no automatic spaces put in for you. Is, and now I can concatenate on the str, because it's going to be a number result, of perimeter. So, looking at this, I have a print statement. I have a string concatenated to a string built from a float, concatenated to a string, concatenated to a string built from another float. Why is perimeter a float? Because side is a float. If side is part of this computation, then this also will have to be a float. Because if this has fractional components, this is going to have fractional components. Square root returns a float value. Okay, so even if this were not a float, this will be a float. Either way, the result will have to be a float to take care of the possible fractional component, the part which has decimal and fractional units. So we're going to print the result of that. Okay, area of an equilateral triangle of side. We're going to do the exact same thing we just did, plus the str of side, plus means concatenate in this sense, is, and then we're going to put area in here. Okay? So let's recap. This is a block comment. This doesn't get executed. That's for my benefit. That just tells me what this is about. This single line comment tells me that what is about to follow will be inputting that length. I probably should have put in a single line comment, compute the perimeter and area based on the side. Explain what we're doing, computing the perimeter and the area. Normally you wouldn't have to outline the mathematical formula, but if it were really complex or came from some sort of source, you might quote the source. And then finally report the results. Now we usually don't leave a space between each one of these, so I'm going to tighten it up. And that's what your program will typically look like. Okay? So you will have a block comment at the top identifying what the program is. Right? You will have the author's name and the date. Now your instructor may get you to use a more formalized form at a later time, but for now, this is a block header comment. And then I'm using individual line numbers. We don't have to comment every single line that we do, but we have to comment the parts of the program so that somebody would understand what it is we're doing. We're going to get information, compute, and report. So input, processing, and output. 3 absolutely essential components of any computer program. Let's run it and see if it works. Enter the length of the side. Well, we have an example on our slide that showed us 3.5. Now we said the perimeter should be 3 times that, 10.5. And I believe we said that if we were to use that number, we would get a rough answer for the area of 5.3. It will have more decimal places, but roughly 5.3. Let's see if we get that. Oh no! We have an error. Math is not defined. Well, I did mention this earlier. I said, hey, there's going to be a problem later on that we will have. So exit code 1 says this program did not complete. What we need to do is up here, we need to import required libraries. Well, there's only one in this case, but we are going to import math. This means that we are going to use predefined code that somebody else wrote for us to do these math operations. In this case, to take the square root. So let's have a look and see exactly how it works now. Enter the length of the side, 3.5, and it says perimeter of an equilateral triangle of side 3.5 is 10.5, exactly as we expected. Area of an equilateral triangle of side 3.5 is 5.30440. You get the idea. Roughly 5.3. So, yeah, this looks like it works. But of course, the beauty is I can put in any value I want. If I put in 1 for the length of the side, the perimeter should be 3 times 1 is 3. The area should be the square root of 1. Well, the square root of 1 is 1. Divided by 4, that's 1/4, times the side squared. Well, if the side is 1, math.square root of 3. I made a mistake there. Math.square root of 3, that's still going to be the square root of 3 over 4. But it's going to be multiplied by 1 squared, which is 1. So let's see what it comes up with. So the perimeter would be 3, but the area would be 0.43301, etc. There you have it. So that's how we solve problem 3. So this week you've learned a little bit about how programs are written and entered into the computer, how we know when there's been a problem and how to look to fix it. We've learned a little bit about how the programs are stored on our computer and how we could archive them together for a submission. But we've also learned some very important things. How to print things out on the console, how to accept input in from the console, how to store things in variables, and how to do some fundamental computations. We've also seen how to import the math library. Now, you normally would do that a little bit later in the course, but this is an intro, so we want you to get a feel for actual computation that would happen in a real course. So hopefully this has helped you to understand just what computer science is about and feel comfortable about what you're going to experience during your first week or so at UPEI. We look forward to seeing you.